So now we see the intersection of sets. We'll see it with a few examples as well. Okay. So as per the definition, what is intersection of sets? So intersection is just like the AND gates which you use in your computer science. So as per the definition of intersection, A intersection B, it is defined by the element X which is present in A and it is also present in B. That is, it should be common in both. Okay, we'll see and try to understand it with example. So let's take the same set once again, the set A which is A, B, C, D and Y. Okay, I'll take other set, the set B which is P, Q, C, D, Z. Again same, again the same set C, and I'll first of all again make the Venn diagram to understand it in a better way. So this is the same Venn diagram for the same set. Now to understand the intersection of sets, we'll find A intersection B, B intersection C, A intersection C, A intersection B intersection C. Okay, so now let me just make you understand what is exactly the intersection. So as per the definition, if there are two sets A and B which are given here, the set A and the set B, so the definition says that the element should be common in both. So let me show you with a marker or a highlighter that this particular region which I am highlighting inside, this is the intersection of A and B, right? Which I have highlighted as yellow. Okay. So this is the common portion and the elements which are coming in common are C and D. So we'll write A intersection B as the elements which are common, and we can say that these are C and D. Now similarly we'll find B intersection C. So the elements which are common in B and C are C and Z. Okay, so we'll write in the roster form as, we'll highlight this and we'll highlight this portion as gray. Okay, so this is the highlighted portion and the elements are C and Z, so we can write in the roster form as C and Z. Now we'll find similarly the intersection of A and C. So now from the Venn diagram we can see that the elements which are common between A and C are C and Y. Okay, so the highlighted region which is gray here, it shows the intersection of A and C, and we'll write the elements which are coming in A and C in the roster form, which are C and Y. Now similarly, the last case which you have to find is A intersection B intersection C. So let's try to understand it. Now A intersection B intersection C, what does it mean? It means simply that the element should come in both the three elements. Okay, so from the Venn diagram, what we can see here, is there any element which is coming in all the three elements? on the all three sets. So we can see the set A here, the set B here, and the set C here. So there is only one element C which is common in all the three sets. So from here we can conclude that from the shaded portion which is showing the A intersection B intersection C, and all the elements which will come in this particular portion will be the part of A intersection B intersection C. So we can write A intersection B intersection C as the set C, the element C in this particular set. Only the element C is coming. Okay. Now here also there are some laws which this particular operation follows. So we'll see some of those laws. First is the law of commutative commutation, or you can say that commutative law. It says that A intersection B equals to B intersection A. So it is just the reversal of the operation. Whenever you interchange the position of the sets, it doesn't make any change difference. Then again the same law, which is the associative law. So it again is applicable for three different sets, that is A intersection B intersection C. If you combine two two sets at once and then you take a intersection with the third set, similarly you can just interchange here A intersection B and then make the intersection with C. It will make no difference. So the third law is this is also an important law, which is the law of the identity element. It says that if you find the intersection of A and the set phi, which is the empty set, what will be the result? The result will be the empty set, because the empty set does not have any element and A has its own elements, but the common thing will be phi. Okay, so this is the law of universe, or you can say the universal law. It says that if you find the intersection of A and the universal set, so it will be only the set A. Now let's come to the next law, which is idempotent law, which says that if you find the intersection of a set with itself, then it gives the same set. Now there is one more additional law which comes here, which is the distributive law. So it says that whenever you find the intersection of sets with a union of two different sets, for example A intersection B union C, it the intersection distributes over the elements B and C, as we can see here, A intersection B union A intersection C. So this is called the distributive law. So from here we have understood commutative law, associative law. These both are common in both laws of union and laws of intersection. This is the law of identity element, law of universe. This is law of idempotent law, or this is the distributive law. Now let's try to understand. There is one more important type of sets, which are mutually disjoint sets, which comes under the category of intersection. What if there are two different sets which don't have any common element? That means the set A intersection B is phi, means A and B don't have any common element, दोनों में कोई भी common element नहीं है, then they are called mutually disjoint sets. Okay, so this is something you should know.